Good morning, 5th graders. I hope you're doing well. It has been a really hot weekend, and I hope you had a great weekend, whatever you did. But I would like you to do your Tuesday check-in through Flipgrid and tell me, how was your weekend? How did you beat the heat? So in there is already my Flipgrid and what we did this weekend to beat the heat. So I want to know, what did you guys do? And that helps us to connect, and especially on the days that we don't see each other like today. Okay, let's talk about your agenda today. So today, if you haven't finished your milestone, please finish it. I need you guys to finish it, okay? And then we're also going to be working from our book today. We're finally in volume 2. Whoop, whoop. And we are working on multiplying decimals today. So we're working on page 313 through 316. And then you have ST Math, of course. And then we also have science. So today's science lesson is specifically on the food chain and abiotic and biotic factors. And there are passages for you to read and an activity. It's a very quick, short activity where you're writing down the important information from the passages. And if you need support, I did create a video specifically for these passages. If not, the PDF is in there for you to print out, or you can read it from Canvas, and then you'll be done. And that's it. So let's go ahead and get straight to our lesson today. So let's look at what we're going to be doing. So it says Padma bought 3 pounds of grapes. Each pound of grapes cost $2.75. How much money did Padma spend on the grapes? Okay, so we're multiplying, and we know that we're multiplying because it says how much money did Padma spend on grapes. So that means we're finding a total. And if we're finding a total, then that means we're either adding or we're multiplying. So we're going to multiply 3 times $2.75. Okay, let's go ahead and do that. So I'm going to do this in red here. So we have $2.75 times 3. Okay, so $2.75 times 3. So this is, do you remember what way this is, what strategy we're using when we multiply it like this? It's called the standard algorithm way. Yeah, so 3 times 5 is 15. 3 times 7 is 21, plus the 1 on top, so that's 22. And then 3 times 2 is 6, plus the 2 on top is 8. Now, if you couldn't tell with what I just did, I just multiplied like normal. I didn't line up a decimal. I didn't try to deal with a decimal. All I did was multiply. And I multiplied like normal, and I got 825. But now what I'm going to do is put the decimal in at the end. So I'm now done multiplying, and I'm going to go ahead and put the decimal in. So I have 2 spaces after my decimal. So I'm going to also have 2 spaces after my decimal here in my answer. So I'm going to put my decimal here, so then I have 2 spaces after my decimal. So that means she paid $8.25 for her grapes. Okay? Now we're going to do it the area model way, because that's what we did when we multiplied too. Okay? So I'm going to do my area model right here. I'm going to first break up my $2.75, and I'm going to break it up into expanded form. So I'm going to break up each value, okay? So I'm going to start with $2, and then I'm going to break up 70 cents, and then I'm going to break up 5 cents. Okay? Oh, you guys can't see that. Let me move my camera. There we go. Okay, sorry about that. Okay, and then we have 5 cents. So now together we have $2.75. And now we're going to multiply that by 3. So here becomes my area model. Now we're going to multiply each value. So we're going to do 3 times $2. What's 3 times $2? $6. And what's 3 times 70 cents? So basically, think about what's 3 times 7. It's 21, right? And then we have our 0 on the end. And then there's 2 spaces after the decimal. So 1, 2. So that means that's $2.10 for this one. And then 3 times 5 cents. So 3 times 5 is 15. And there's 2 spaces after the decimals, so my decimal's going to go here. And now I'm going to add all that up. So I'm going to put my values over here. $6 plus $2.10 plus 15 cents. And I'm going to put my placeholder 0 here. Now when I'm adding decimals, yes, I have to line up all of my decimals, okay? And so here all my decimals are lined up, and I can go ahead and add straight down. So I have 5, 2, and 8. And that is the same thing as right here. So I know I'm correct, okay? And that's how you solve that. Okay, let's go ahead and now look at the next page in our book. So it says you can use decimal grids to picture multiplying decimal by a whole number. Think of 3 times 275 as 3 groups of 275. So here's 1, 2, and 75 cents. 1, 2, and 75 cents. 1, 2, and 75 cents. So we have 3 groups of $2.75. So if we were to add that all together, we would have 1, 2, 3, 4, 5, 6 wholes, which we knew from when we did our area model. And then we would add our 75 plus 75 plus 75. And then that would give us the rest amount. Okay, and then here's our standard algorithm way. Well, actually, no, this is our partial products way. So this is actually the same way we did in our area model, where we had 15 cents, 210, and 600. So that was $2.10 and $6. And when we add that all together, well, it's similar to our standard algorithm too, because we did 825 as our answer first, and then we put in our decimal at the end. So there's lots of different ways for you to solve this problem. Let's look at number 1. To solve the problem, you need to find 3 times $2.75, estimate the total cost of the grapes, and explain your thinking. Well, a way we could estimate is if we multiply 3 times 2. 3 times 2 is 6, but this is actually really close to $3, isn't it? So if we estimate, we could even say that 3 times $3 is $9, and 825 is closer to $9 than it is to $6. So there's lots of different ways you can estimate this. We could say 3 times 2 is $6, and then this is probably going to be like an extra dollar, or 75 cents times 3. So that would be what, $1.50 extra. So if we have 6 plus another $1.50 at least, at the very minimum, that would be $7.50, and then that would get us really close to $8.25. Or we could round $2.75 is really close to $3, and 3 times 3 is $9. So we could estimate it that way also. Okay, let's look at number 2. How many full grids can you make? How many full grids can we make? Well, 75 cents, so let's actually add that up so you guys can see a visual of that. So I'm going to erase the work that we've done here. And it says how many full grids can we actually make? So we're going to add up all of those grids. So we had 2 full grids and then 75 cents. I'm just going to put 75 cents, okay? And then we're going to do 3 groups of these. So we have 1, 2, 3, 4, 5, 6 full grids. And then we are for sure going to get another 1 or 2 full grids out of here, right? Because if we add 75 cents plus 75 cents, we get 10, 14, 15. We get $1.50. That's a whole nother full grid here, okay? and then that's a half a grid, so I'm going to put a half a grid right here, and I'm going to cross that out, and I'm going to cross that out. So right now we have a half a grid and a full grid, but we have another 75 here. So I'm going to add another 75, and that's going to be, oh, I'm not subtracting, what am I doing? That's 5, 12, 2. So then that's the other half a grid here, or full grid. So then we have another one. And now we have 6, 7, 8, and then we have 25 cents. So that's just a small little part of the grid. And then we can cross that one out. So now we have 1, 2, 3, 4, 5, 6, 7, 8 full grids. So the answer to question number 2 is 8, because we have 8 full grids. Okay, so then the next question is, oops, I went too far. Okay, so we're going to put an 8 in this blank right here, and then how many squares would be shaded in the partially filled grid? And right here we would put 25. So 25 would be partially shaded. Okay, number 3. How is multiplying with a decimal like multiplying with a whole number? So let's answer that one together. How is multiplying with a decimal like multiplying? Well, it's the same because we're still multiplying like normal. The only difference is we'll add the decimal at the very end. So that's what we're going to write. Just a quick little sentence. They are the same. Can you see that? So you're going to multiply like normal, but then we will add the decimal at the end. But you add the decimal at the end. Okay? Can you guys, here, can you see that? There you go. So they are the same, but you add the decimal at the end. Whoops. Okay. Now let's look at the next question. The next question says 825 hundredths is the same as how many ones? Okay, so this is what this looks like. I'm going to erase all of our work right here. And we said that when we multiplied, we got 825. So it's saying 825 hundredths is the same as what? How many ones? So what we're going to do is we're going to put this in our place value chart. So if this is hundredths, that means this has to end in the hundredths. That means this is going to be tenths, and this is going to be ones. So 825 hundredths, because that means the 5 has to end in the hundredths. That's when we talked about our decimal place value several weeks ago. So now this is saying 8 ones, 2 tenths, and 8 hundredths. So our answer is going to be 8.25 on the blank for number 4. Okay. So now let's look at number 5. Number 5 says 3 times 2.75 is, well, we already answered that, right? What is 3 times 2.75? 8.25, right? Okay, then next, it says, is the product reasonable, and explain. Yes, because remember when we estimated in number 1, we said what was 3 times $3? Because when we did 3 times $3, that gave us $9, and that was our estimate. That was back from number 1. Is $8.25 close to $9? Yeah, it's only a 75-cent difference. So we know our estimate is reasonable because it's close to $9. So we're going to say yes because it's close to $9. Okay? All right, now let's look at number 6. I want you to cross off. We're not going to do number 6. No, not to number 6. So number 7, we're going to do number 7 now. Number 7 says to reflect, so that's on you. You're going to reflect on this question. What strategy works for you? Do you like multiplying a decimal by a whole number where we did the standard algorithm, or we did the area model, or do you like the way where it shows the pictures, the grids? Which way, and there was also the partial products way that the book showed too. So which way works for you? What did you like best? Okay, now let's do number 8. So number 8 says, onions cost 65 cents per pound. Sasha bought 4 pounds of onions. How much did she pay for the onions? Show your work. Okay, so for this one, I'm going to go ahead and do it the area model way, okay? And then the next one we'll do our standard algorithm, okay? So number 8, let me erase. So number 8, we have 65 cents. And we're timesing that by 4 because she's going to buy 4 pounds of onions. So that means it's going to be 65 cents per pound. One way we could do it is we could do repeated addition, 65 cents plus 65 cents plus 65 cents plus 65 cents. So there, as I said before, there's like a multitude of ways for you guys to do this. I'm going to go ahead and do our area model way for our visual learners, okay? So I'm going to break up 65 cents. So I'm going to do 60 cents, and then I'm going to do 5 cents. And then I'm going to times that by 4. Okay? So let's do 4 times 60 first. What's 4 times 60? 4 times 6. Do you know what 4 times 6 is? 24, right? And then times 60 means it would be 240. So 240. There's 2 spaces after that decimal, so I'm going to do 2 spaces after this one and put my decimal point right there. Okay? Now I'm going to do 4 times 5. What's 4 times 5? 20, right? Here's my 20. I'm going to do 1, 2, 1, 2. So that means my decimal point goes right before the 20. Okay? Now I can add this together. So I'm going to do that right here. I'm going to do $2.40 plus 20 cents. And I'm going to put in my 0 as my placeholder here. Remember, when we're adding decimals, our decimal is lined straight up, okay? Because then our place values are lined up. So 0 plus 0 is 0, 4 plus 2 is 6, and then 2 plus 0 is 2. So her total price per for the 4 pounds is going to be $2.60. Now I'm going to check my work though, because I want to make sure I'm right. And I'm going to use repeated addition since we were just talking about that. So I'm going to do 65 cents 4 times. So 0.65 plus 0.65 plus 0.65 plus 0.65. So here we go. Let's see if I got it right. 5, 10, 15, 20. And then 6 plus 6 is 12, plus the 2 on top is 14. 14 plus 6 is 20. 20 plus 6 is 26. So here's my 6, carry the 2, and I get 2. And my decimal point comes straight down. There we go, and I checked my work. Okay? All right, so we know we're correct. So on the solution line, I'm going to put $2.60. Let's look at the next question. Number 9 says, Brian makes a row of 11 paper clips lined up end to end. Each paper clip is 2.48 centimeters long. How long is a row of paper clips? Show your work. Okay, so what we're going to do right now is we're going to do our standard algorithm way. So let me erase my board here. And Brian's making a row of 11 paper clips. Okay, so that's 11. And he wants, each paper clip is 2.48 centimeters long. Oh, not 45. Oopsies. 48. And I'm going to multiply that. Okay? And remember, when we're multiplying, we don't have to line up the numbers. Okay? So I know mine looks kind of weird, but we're just going to multiply. Okay? So let's just forget the decimal right now, and let's just multiply. So I'm going to do my first row in blue and my second row in red so you can see the difference. So here's 1. 1 times 8. 1 times 4. 1 times 2. Okay? And now my ones place is done. I'm going to cross that out. And I'm going to put a 0 down here for my placeholder. And now we're going to do our one that's in the tens place. So this one right here. 1 times 8. 1 times 4. 1 times 2. And now let's add it. So we have 8, 12, 4 plus 2 is 6, 7, and then 2. And now here's where we put the decimal back in. So we count how many spaces are after the decimal. We have 1, 2 spaces. So I need to have 1, 2 spaces from the end, and there's my decimal. So all together, his paper clips are going to be 27.28 centimeters long. Okay? I want to show you another way to do it. So this is kind of breaking this up into parts that we know. So what we call that is a distributive property when we break it up into parts we know. So what we could do is we could take 2.48 centimeters, okay, and we're going to actually keep that the same. But I'm going to take 11 because I can break 11 up into 10 and 1, right? So I could do 2.48 times 10, right? And that times anything by 10, it normally comes easy, right? So I put my 0 here at the bottom, and then I do 1 times this, and so it becomes 2,480. And then I do my decimal, 1, 2, 1, 2. But I still have that 1 left over because it's 11, right? And I still have the 1. So now I'm going to add to that the 2.48 here. And now I can add that, and that becomes 8, 12, and 7, and 2, and I bring my decimals straight down. So what we just did is we just broke up what we knew, and we broke up our 10 and we broke up our 11 into 10 and 1, and that's called a distributive property. It's also called partial products because we found the different products first. And I didn't need to multiply 2.48 times 1 to know that it's 2.48, so I just went ahead and added it. But what we just did was 2 problems, and then we add them together. And that we learned with our partial products when we did multiplying whole numbers. Okay? So what you're going to do is you're going to do number 10 as your exit ticket. I'd like you to do number 10 and check your answer with the answer key in Canvas, and then you're done. And we will do the next set of pages tomorrow. Just a reminder, do ST Math. Since you're doing this with me right now, you're practically done. You just have one more problem to do. So ST Math and then Science, and finish your milestone if you haven't finished it, please. And go on to Flipgrid. Tell me how you're doing and how your weekend was. Okay? All right, miss you guys. Bye.